Okay, so let's go through this question A together. So the diagram shows a trapezium ABCD, right? Where A is this, B is that, C is 6, 1, and point D is 0, K. So this one is your y-intercept. And they say that AD is parallel to BC and the y-axis bisect angle ADC. So for this angle, right, this angle is being bisected. So means that this will be, let's just say I put in some values, 30 degree. This will also be 30 degree. Okay. So part I, express the gradient AD and CD in terms of K. This one is quite simple for this. Okay, so for this, right, you just need to use y2 minus y1. So what is, okay, so for gradient AD, right, gradient of AD is equal to K minus -1. So divide by 0 minus -8. So it's roughly equal to K plus 1 over 8. So that's the gradient of AD in terms of K. So next will be your CD. So CD is M equal to, gradient of CD is equal to, okay, so first you just use, okay, maybe I just use this lah. So K minus 1 over 0 minus 6. So it's roughly, okay, let's put in K minus 1 over -6. So that's the gradient of CD. Okay, the next part is part 2. Hence, show that K is equal to 7. Okay, so for this question, right, we will need the help of Tuakaso already. So, okay, so first thing, let's determine this big triangle first. So you notice that I draw a dotted line, right? So it's like this. Then after that, like this. Okay. So first thing first, we know that this is a right angle triangle. So, okay, so let's determine what is this length. Okay, and just remember when we are putting down this length, make sure it's positive. Because when we deal with Tuakaso, normally the adjacent, opposite, and hypotenuse, they are all positive. Okay, so if you look at the x coordinate, this is -8, you translate or you move all the way to this point, right, should be +8. So don't put -8 because -8, this will cause later when you do the calculation, it's impossible to find K to be 7. Okay, next thing is let's do the vertical part. Okay, vertical part, you notice that this is, I start from here and I go all the way to here. Sorry, it's not here. Okay, so it's here. Okay, so I go all the way to this part. So you can see that, okay, this part actually is, okay, so I start from K, I go to -1, right? So this length is roughly K minus -1, which is equal to K plus 1. So in this case, I already know, this one is known as the opposite. This one is known as your adjacent. So this adjacent. So first thing I just write down tangent theta. So what is the theta? The theta here will be this. So this is the theta here, or just this part. Okay, so tangent theta is equal to oppo over adjacent, right? Because it's 2, so it's 8 over K plus 1. Okay, so that is for tangent theta of the big triangle. Now I move on to the small triangle. Okay, small triangle you can see is here. So it's this. Okay, let me just erase first. Okay, so the small triangle is this part. So, okay, let's label. Okay, so let's label this theta. Okay, why can I label this theta? Because notice one thing about this question. They say that the y-axis bisect. Bisect means I cut the angle, right, into equal parts. So this is theta, this is also theta. Okay, so let's determine the opposite and the adjacent first. Okay, so what is the opposite? Opposite is, okay, so of course, you see this, right? 6, right? Okay, so this length is roughly 6. And then of course, the adjacent right here. Okay, so this is the adjacent. So this adjacent is, okay, so of course it's K minus 1. Because this is the y coordinate. So the length of this is K minus 1. Because K minus 1 is confirmed positive. Just make sure that the opposite adjacent hypotenuse, they are all positive. Okay, so next so now I write down tangent theta. So tangent theta is equal to 6 over K minus 1. Okay, so since they both equal because they're both the theta is the same, so means that the tangent theta should also be the same. So I just put down this, right? So you equate this with this. Then you confirm you can get the k equal to 7. So let's see this. Let's find out this together. So 8 over k plus 1 is equal to 6 over k minus 1. Then you do your cross multiplication. So this is 8k minus 8 equal to 6k plus 6. Okay, so move all the alphabet to the left hand side. So this 2k, then of course this will be 14. So k is equal to 7. Yeah, so as long as you show this, then it is good enough. Okay, all right. So yeah, so of course, let me just go through the part 3 also. Okay, find the value of h. So this one is actually testing you on the idea of, do we know that the gradient, if the two lengths are parallel, right? Do we know that their gradient is actually the same? Okay, so since I already know what's okay already, right? Okay, so I can submit now. So this will be 7. So in the event that you couldn't find k equal to 7 in exam, right? It's okay, you just code them. So you just code, I just code part 2, k equal to 7. Then you move on to part 3, part 4, part 5. Right? So okay, so now I determine, okay, now my gradient of AB, right? If I use just now this thing, so k, so this is 7 plus 1 over 8, so which is equal to positive 1. So the gradient of AD actually is a gradient of 1. So of course I know that my BC confirm is also 1. Okay, next thing is I determine. So I just use y2 minus y1. So so gradient of your BC is equal to 1 minus negative 9, right? So it's plus 9 over 6 minus h. So this is the gradient of your BC. So I know that the gradient of BC is actually equal to 1. Then you do your cross multiplication. So of course 10 over 6 minus h equal to 1. 6 minus h equal to 10. So of course minus h equal to negative 4. So h is equal to minus 4. So in this case, I already find the value of h. Okay, next thing, part 4. So part 4, show that the angle ABC, right, is not 90 degree. So of course, if two lengths they are perpendicular, right, I can actually show that they are 90 degree by multiplying their gradient together to get the result of negative 1. So just remember that, okay, for example, let me just do a very quick recap. So for example, let's just say I have a gradient here and a gradient right here. And if they are perpendicular, right, they have this relationship. So first, the red color gradient is, for example, 2. 2 over 1. Then after that, the purple color gradient is, okay, so you must flip. So it's 1 over 2. And don't forget to change the sign. So this is your minus. Of course, the red color gradient is plus. The sign must change, which is consistent with the picture, because you can see that from the picture, right, this is the positive gradient, this is the negative gradient, right? Okay, so now I go to ABC. So ABC is here. So I need to show that the gradient is not 90 degree. So I just need to, okay, let me just erase this first. Okay, since I already know my h, right, my h is roughly negative 4. So this is negative 4. Right. Okay, so first thing first, let's determine your AB, the gradient of AB, because I already know my BC already. My BC is positive 1. So let's determine your gradient of AB. So gradient of AB is, okay, so just use minus 1 minus negative 9 divide by negative 8 minus negative 4. So it's equal to maybe 9, okay, this 8 on top, then negative 4. So this is negative 4 at the bottom. So it's equal to minus 2. So you can see the gradient of your AB is minus 2. The gradient of BC is is equal to 1. So definitely if you multiply them together, it's not going to give you -1. So hence I show that they are not 90 degree or they are not perpendicular. Okay, okay. So the next thing is so this is to find the area of trapezium ABCD. Okay, so of course the trapezium, right? Just remember to tie the shoelace. So how do I tie shoelace? Very simple. First thing, let me just sub in first. Okay, let me just erase. Okay, so sub in. So first thing, maybe I start from point number A. Then I go, remember, it's always to go anti-clockwise. So I go to point number B. After that, I go to point number C. I go to point number D and go back to where you start. So, okay, so let me just write here. So first is I start from A. So half, then you put a vertical line. Okay, so since you start from A, right? So -8, -1. And next is -4, -9. Next is your 6, 1. Next is your 0, 7. And the last one is your back to where you started, right? So -8, -1. Then put a vertical line. So first, always write down this half, then put a square bracket, round bracket. So first you tie down first. So tie this, tie this, tie this, and tie this. Okay, so -8 times -9 is around 72. Then -4 times 1, -4. 6 times 7, 42 plus 42. And after that, 0 times -1. This one don't need to say lah, 0. So put a round bracket. Okay, now you always put a minus sign. Okay, now you put a round bracket. So first, tie up. So 91, 94 is positive 4. -6 times 6 is 9 times 6, sorry. So it's -54. So after that, 1 times 0, 0. 7 times -8, around -56. And put a round bracket, square bracket. Okay, let's calculate. So first, let's calculate the round bracket. So 72 minus 4 plus 42, right? So it's roughly 110. So now I put a minus sign and put a, let's calculate this part. So 4 minus 54 plus 0 minus 56. So it's a negative number of 106. And put a round bracket, square bracket. Okay, so I do the inner bracket first. So 110 plus 106, around 216. So 216 divided by 2 is 108. So the area of the trapezium is roughly 108 units square. Alright, so I hope this clear things up.